the gas law. We're going to look at Boyle's law, which relates the pressure of a gas to its volume if you hold the temperature constant. So what I have and what I'm going to use is a simple tire pump. When I pull up the handle of the tire pump, it draws a sample of air of a given amount into the tube and a given volume. Now, normally I press it down and it goes into the tire. But what I'm going to do now is clamp it shut so that any air that I draw in, when I press down on the plunger, it will decrease the volume of this sample of air, but the air won't have anywhere to go. It won't be going into a tire or anything. So I'm going to clamp it, sealing up its outlet. Then I'll draw some air into the cylinder and reduce the volume. Remember, the air comes in elsewhere through a valve arrangement and is pushed out here normally. So we'll be able to draw air into it, but the air can't come out. We'll have a sealed sample once that happens. So here's our apparatus down on the floor where I can use it. And we're looking right down on the pressure gauge. So I'm going to draw in a sample of air. Then we'll press it. Remember, I'm going to be decreasing the volume of the air inside that tube when I press the plunger down. And we see that the pressure goes up. When I release it, the pressure starts to go back down. So let's review that. When I drew the sample of air into the pump, I had a fixed volume. It was plugged at the end. When I pressed down, I decreased the volume. The piston in here came down and the volume decreased. And as we saw, the pressure increased. And as I increased the volume, the pressure decreased. Decreased volume, increased pressure. That's opposite directions. That's inverse proportionality. Hi everybody. Today we're going to take a different look at Boyle's law. That's the law that relates volume and pressure to each other. Volume is inversely proportional to pressure. To do this demonstration, we're going to use an apparatus that consists of a clear plastic tube, a dowel to work as a plunger that goes into that plastic tube, and a potato. Here, I've placed the potato on the ground. I'm going to take my clear plastic tube, hold it between my feet, and make a plug in one end of the potato. You can see, or in the tube, there's a potato plugging one end of the tube. Then, I'm going to put a plug in the other end of the tube. Now, what I have is a sealed sample of air. The potato plugs make very effective seals, sealing the sample of air. Then, I'm going to take our plunger I can get it a little bit closer here. And push it in. as I do this, I'm decreasing the volume of the sample of air inside this. So expect the pressure to increase a little bit. We're gonna decrease the volume a lot more by pushing in on this plunger rapidly. We'd expect the pressure to increase in it until it gets great enough to expel the other plug out of the other end. So basically we've made a small potato can. So, by the way, we're in Columbia 150, one of the largest classrooms on campus. So as I push this plunger in, it should decrease the volume of this sample of air, increasing the pressure until we eject it. Let's see if it works. I hope it does. I think it got stuck somewhere up there. So as I push on this plunger, it should decrease the volume of this sample of air, increasing the pressure until we get enough pressure to pop out that plug on that end. At least I hope that's what's going to happen. Let's try it. That worked.